afternoon, my name is Rob Winch, and I'm the Spring Security Lead at SpringSource VMware. Today we're going to be talking about getting started with Spring Security 3.1. Starting off, a little bit about myself. I'm the Spring Security Lead at SpringSource VMware, as I mentioned before. I have over 15 years of web experience and over 10 years of Java experience. I've been employed at a number of other places prior to SpringSource, and probably the most relevant for this presentation is did over 7 years of healthcare security at Cerner Corporation. So today's agenda, we'll start off by talking about what Spring Security is and how it can benefit you. And then we'll discuss how to set up a basic Spring Security application. And after we set it up, we'll walk through how Spring Security is working behind the scenes. So afterwards, you should have a pretty good understanding of how all the pieces fit together. Then we'll do some very basic customizations, including a custom login page and a login controller. And we'll wrap up with global method security, and if we have time, maybe a little surprise at the end. So, and also Q&A. So a little bit about Spring Security before we get into all the details is formerly known as a CG Security. So if you see a CG Security, know that they're one and the same, but also know that a CG Security is no longer actively maintained. So it's important to realize that you want to start with the Spring Security code base or migrate to the Spring Security code base if you are starting a new project. And Spring Security is divided into two main concepts, authentication and authorization. Authentication describes the who, or who's trying to access a particular resource. And you can identify that in a number of different ways. For example, username and password. And you can store that username and password in a number of different ways, like a database or LDAP. Spring Security provides support for both of these out of the box. And if you're storing those credentials, you want to make sure that they're secured. You've probably seen that a number of websites have been compromised, had their passwords exposed for their users. Spring Security provides a password encoder interface to ensure that your passwords are hashed and salted to ensure if your data store is compromised, your users' passwords are not. It also offers a number of single sign-on solutions like CAS and OpenID. CAS is a standard single sign-on protocol for basically anyone to use, but a lot of the academic world uses it because it's free and it supports a lot of features like single logout. OpenID is another standard single sign-on protocol. Some of the giants like Google and Yahoo use it, so if you're interested in integrating with them, that's one way of doing so. And Spring Security also provides a pre-authentication module or support, and the pre-authentication support is basically if you don't want to authenticate with Spring Security, you can still use it. So say you were using something like SiteMinder, which injects a header into your application to determine what your current user is. Spring Security can still be used. You might ask, well, if I'm already authenticated, why would I use Spring Security? And that's the next aspect, authorization. Given I know who is trying to access a particular resource, are they allowed to access the resource? And in a web-based application, this is oftentimes done by URL-based security. And in Spring Security, among other web applications, it's implemented using filters. And so filters play a primary role in securing your web application with Spring Security. But URL-based security is not necessarily enough. And that's because URLs can be manipulated and you can have things like relative paths. And it can actually be very tricky to restrict access to domain-level objects with just URL-based security. And therefore, it's best to have also method-based security. And here, Spring Security leverages Spring's AOP support to add aspects to your service tier to secure your service tier for you. And so you can't invoke the method unless you are granted access to invoke that method. And finally, Spring Security has a number of extensions. And these extensions demonstrate that while Spring Security is simple, it's also powerful. It wasn't initially designed for things like Kerberos or OAuth, not specifically in mind, but there are extensions for OAuth, Kerberos, and SAML that exist that are built on top of Spring Security. And this should give you some confidence because in the corporate world or any application that you build, you're going to have custom requirements. And so it's nice to know that the framework can support those custom requirements but still give you a lot of benefit to get up and running quickly. So before we get too involved, we're going to do a very quick servlet filter review. And I'm sure that most of you understand filters very well, but there's two misconceptions or misunderstandings that really make it difficult to understand Spring Security that we're going to clear up, and we'll go through this pretty quick, so just bear with me if you understand everything, but we'll get started on the rest of the content very shortly. So here we have a very basic web.xml. There's nothing fancy about it. We map filter1 to every URL. So now we have the code for filter1. And filter1 does nothing fancy either. It basically prints out a statement before it invokes the rest of our application. And we'll notate the greater than sign as before request URL. And we'll trace through some requests in just a second. And then we run the rest of the application. And then after that, we print out after request URL. So the less than sign we notate as after request URL. All right, let's see what happens when we make a request to our application. Here you see we make a HTTP GET to our home URL. The first thing that happens is the servlet container recognizes that the filter1 is intercepting every request. There's nothing surprising here. But the one thing that I do want to point out is there's nothing magic about filter1 do filter being invoked. It's just a method call. So here, the container is just invoking this method. And these interfaces that exist are just interfaces. So we could implement the servlet request ourselves. It's just an interface. We could implement servlet response ourselves. Just an interface. Same thing with FilterChain. And in fact, Spring Security does a lot of these things and replaces it with replaces the current applications implementation with an adapted version. And so we'll get into that a little bit later, but just realize this is just a method call. And so the very first thing that would happen when you invoke that is you'd print out before home. And that's nothing surprising again. And then the next thing that happens is the filter will invoke the filter chain. And this demonstrates aspects in a web-based application. Filters are essentially a way of doing aspect-oriented programming in a web-based application. And it does this in a framework-agnostic way since it's built into the container. So while the filter doesn't know what the rest of the application is doing, it's able to invoke the rest of the application. Here we decide that the rest of the application is going to do a forward to home.jsp. So home.jsp is invoked, and it writes out a response. And afterwards, it returns back up to the filter chain, and that means that our filterchain.doFilter is now completed, and we get after home. And one of the things that you might notice is that we've had two URLs involved, our /home and the home.jsp URL. However, our filter only printed out one of those URLs. And this is one of the first things that people get confused with Spring Security is, well, why isn't it intercepting my forwards or includes or something like that? And that's because filters by default will only intercept HTTP requests. So if you're interested in intercepting other types of requests, you need to update your dispatcher elements in your web.xml. So here we've explicitly listed the request and the forward dispatcher. You have to explicitly list request as soon as you add any dispatcher elements other than leaving it blank. So now we're intercepting requests and forwards. So let's see how our request is impacted by this. We get home, just as we did before, and filter1 is outputting before home, just as before. Now it invokes the filter chain, and it does a forward to home.jsp. And this time, filter1 actually intercepts the home.jsp, and it outputs before home. Home.jsp writes out to the response, and then it returns back up to the second invocation of filter1. It outputs after home.jsp, and then it propagates back up to the first invocation of filter1 and outputs after home. So here you can see that the filter can intercept other URLs, but you need to make sure you configure it correctly in your web.xml. So Spring Security's web support is based upon filters, so it's very important to have an understanding of how they work behind the scenes. And it's rare to use Spring Security with other dispatcher types, but if you're looking for that support, it is there. You just need to be aware of it and how to configure it. And some of the other dispatcher types include request, include forward, and error. All right, so moving on to our second thing, and this is just basically to clear up some confusion around the filter chain. A lot of people feel like the filter chain is just kind of magic. It does some things with the container and then everything continues. But really it's just an interface, and that interface, you can view it as invoking the rest of my application. So here we have an even more basic filter, and it basically invokes the filter chain, and I want you to read it as run the rest of my application. Because if there's another filter in your web.xml, all it's really doing is invoking security filter, if it were a security filter, .do filter. And so you can think of it as an indirect way of invoking the rest of your application. It's just an abstraction over it. And in fact, if there was no other filters and it was just a servlet, it would be servlet.service. Exact same thing. So whenever you see FilterChain, think of it as running the rest of your application. And this is important because in Spring Security, we use filters as building blocks so that you get the best usability, reusability out of Spring Security as possible. So one filter might try to run the rest of the application. And then you might have another filter, say a security filter, and that filter might say, does the current user have access to this URL? If not, it will throw a security exception. And here you can see we can catch that security exception, and then we can handle it by sending a user to a login page, for example. If they're already logged in, you might give them an access denied page. And this is fundamentally how Spring Security's web-based support is composed, is small, discrete units that are very reusable in a web application. So enough with our servlet filter review. We're going to go ahead and demonstrate our web application. And I like to use this application because it's very simple and we can focus on what we're trying to learn. It's a messages application. And all we do is we can list out an application. Maybe we can make it a little bigger for you. Maybe not too much bigger. We can list them out and we can create a new message. We can display that message, list out our messages, and view the details of the message. Nothing fancy at all. I'm sure you guys are impressed by my coding skills. But all right. So now that we've seen our application, we realize that there's no security, and we want to require people to log in order to access it. So let's see how we can update it to add Spring Security to it. So the basic steps for setting up Spring Security are adding Spring Security dependencies, pretty common sense, update your web.xml, and create the Spring Security configuration. The very first step is updating our dependencies. If you're using Maven, it looks something like this. And so you have Spring Security Core, Web, and Config. Core is just that, the core of Spring Security. If you're using Spring Security at all, you're going to need this jar. Spring Security Web is required in any web-based application using Spring Security. And so you might not be using Spring Security with a web-based application, but if you are, you will need this jar. And then Spring Security Config. If you guys are familiar at all with Spring's namespace support, this directly maps to that functionality. And if you're not familiar with it, we'll cover it in more detail, but in summary, it's a declarative way of setting up your Spring Security configuration. Another thing that's important to note is transitive dependencies. These are bringing in transitive dependencies, and most of you are probably familiar with Maven, but one of the things to note is Spring Security's minimum dependency version is Spring 3.0x. If you're trying to use it with Spring 3.1x, and I say x is a variable, then you need to make sure that all your dependency versions match. So basically what you want to do is when you open it up, you can open up your pom.xml, and hopefully you can see this. Probably not. But you can type in Spring, and then you can see all the dependencies. And here you can see that we're getting collisions in our application. So we get Spring AOP 3.07 and Spring ASM 3.12. And if you get collisions like that, you're going to get problems. So make sure you use excludes dependency management or explicitly list the Spring versions that you want. Make sure anything that starts with has a group ID org Spring Framework.security has the same version. Anything that's org Spring Framework has the same version. One of the biggest problems with transitive dependency management is trying to resolve those sorts of problems. All right, so now that we've declared our dependencies with Maven, if you guys are up to date with some of the newer technologies, Gradle's another way. We won't go over this in detail, but if you haven't checked out Gradle, do, because it's a pretty nice framework. But this is how you would declare your dependencies with Gradle. The next step is to update your web.xml. And if you're familiar with Spring at all, with web-based applications, you're probably familiar with the ContextLoaderListener. You add it to your web application, and then you specify the context config location. And what's happening behind the scenes is the ContextLoaderListener is loading the context config location. And it's not specific to Spring Security at all. As I mentioned, you've probably already used this if you've done a Spring MVC application. And what it does is it provides the application context, which is basically Spring's factory. It provides the application context so that the rest of the application can use that to look up your Spring beans. And it's rare to interact with application context directly, but it's also good if you're wanting to know what's happening behind the scenes, how things work. So let's take a look at some pseudocode of ContextLoaderListener, because I think as engineers, pseudocode is probably the easiest way to describe something. So whenever the web application starts up, it initializes application context in our ContextLoaderListener. And it looks something similar to this. And you'll notice that the context config location is specified web.inf spring star.xml. That corresponds to our context config location in our web.xml that we already specified. So this is where all our Spring configuration must be present. You can add multiple lines if you want, but it is important to make sure that all your XML configuration, or if you're using Java configuration, corresponds to this location. Next, the rest of your application can now use application context to look up beans. So it's essentially a factory behind the scenes. But as I mentioned earlier, you will typically not interact with the application context directly because you want to use dependency injection. So, and Spring provides support for you to be able to do this, and we'll cover that in just one moment. So the next step is to update your web.xml with the Spring Security Filter Chain. And for now, know that the filter name is very important because this is basically a keyword within Spring in order to get things set up correctly. And we'll go over that in more detail on the next slide. But for now, know that that's important. And the DelegatingFilterProxy is the implementation of it. Again, it's nothing magical, and we'll actually reveal what's happening behind the scenes with it. But the DelegatingFilterProxy is just another class like you might implement for a filter. And then you would map that to every URL. And typically, when you map it to every URL, you also want to make sure that the filter mapping is the very first entry in your web.xml. And the reason for this is because filter mappings are order dependent. So if you place it after another filter mapping, the filter that's before it will not be secured. There are exceptions to this rule, but do realize that the filter mapping order matters, because otherwise Spring Security will not protect it with URL-based security. Here we have the pseudocode for DelegatingFilterProxy. And basically what happens initially is it takes the application context from the ContextLoaderListener. And it's not really important how it obtains that application context because it's unlikely that you'll ever need to obtain it yourself. And in fact, there's other ways to go about doing it in many instances. But here it gets the application context and it uses it like a factory to get a delegate filter. And the delegate filter is what will do all the work. So you see here it's looking up a bean by the ID of Spring Security Filter Chain. Where does that come from? That comes from our filter name that we declared in our web.xml. So it's important that because we are using the filter name Spring Security Filter Chain, that later we define a Spring bean by the same name. So this is how we tie basically the container, which understands nothing about Spring, for example, Tomcat knows nothing about Spring, to our Spring configuration. So it's important that matches up. And then whenever doFilter is invoked, all DelegatingFilterProxy does is it delegates all the work to the bean that it looked up in Spring configuration. So if that's confusing at all, you can think of it as mapping something in your web.xml to a filter in your Spring bean configuration. That's what DelegatingFilterProxy does. And by default, it'll do it by the filter name that you have specified. So the next step is we need to create our Spring security configuration. And as we mentioned earlier, it needs to correspond to our context config location. So we're going to place it at web.inf spring security.xml. And one of the common problems is making sure your namespace gets set up correctly. So we're just going to demonstrate, hopefully you guys can see it fairly well. We're going to demonstrate how you could do with this with Spring Tool Suite real quickly. If you've already used it, it's not that exciting, but if you've had trouble remembering your namespaces, it can be fairly exciting. So we're just going to put in a dummy.xml instead because we've already created our, if I can type, because we've already created our security.xml file. But basically, you do the next, and then you can check any of the namespace support that you'll need. So here I'll click next, select the security, and you can see here it adds all the namespaces that I need. And if I forgot one or need to add one later, I can use the namespace tag to check the boxes that I might want. So again, if you've used Spring Tool Suite, nothing all that exciting, but perhaps a nice feature of it that you might not know. So now that we've created our XML file, we'll go ahead and move on to, this is just a summary of what we did. We'll go on to what we're adding to our configuration and what it's doing behind the scenes. So here we have an HTTP element, security HTTP. And what this is doing is this is what's creating our bean by the name of Spring Security Filter Chain. And so whenever you look it up in the Delegating Filter Proxy, this configuration is what's creating it. And the very first thing that it does is it says that if any URL matches /*, I'm going to require the role user. So the current user must have role user. And /** matches everything, so basically every request will require role user. If the user is not logged in, then it's going to require the user to log in. And form login is a way of specifying that. That means that if the user is not logged in, I will require them to log in using a HTML form. And in this instance, we don't specify the URL for it, so Spring Security will actually generate the login page for us. And then when you submit that form login will validate the username and password. And how does it do that? It actually asks the authentication manager that you see at the bottom. And here we're using an in-memory implementation of that authentication manager with the user of user, password of password, and roles of role user. And it's very easy to swap this out if you're wanting to use JDBC or LDAP or something else like that. But for demo purposes, it helps us get up and running much faster, so we'll use the in-memory implementation. So now let's see what happens when we use our basic Spring Security setup. The first thing I'm going to have to do is enable the filter mapping. I have all the other configuration we went over set up, but this was just so we could see what the application looked like prior to Spring Security. And we're using an in-memory database, so all our objects will be gone since we restarted. And here you can see that when I tried to access a URL within my application, it sends me to this login page. And again, it's not very pretty, but we didn't have to do anything to generate it. We'll demonstrate how we can customize this in a little bit. And right now it's using admin, but we don't really have an admin user. And so we'll use our regular user. I just logged in, and now I can do the same operations that I was able to do before. Again, nothing that exciting after we've logged in, but it was very easy for us to add username password-based authentication to our application. And if you wanted, you could easily swap out to a database or LDAP just by updating your Spring Security configuration. So how is this working behind the scenes? We said that the HTTP element is creating our Spring Security Filter Chain. But what is it doing behind the scenes? Behind the scenes, it's creating an object called FilterChainProxy. And what that does is it's very similar to our DelegatingFilterProxy, except it's a little fancier. Instead of being a single delegate filter, it is actually looking up the filters, plural, that it will invoke for this particular request. So it'll look up all the delegates, and then it'll iterate over each of them, invoking the filters do filter method each in turn. And so this is how we are able to create multiple filters in our Spring Security configuration and only have a single filter in our web.xml. And it'll continue iterating over those as long as the FilterChain.doFilter method is invoked. And afterwards, it'll continue with the original filter chain. And so if this is confusing at all, think of it as a one-to-many mapping. You have one filter in your web.xml, and it maps to many filters in your Spring Security configuration. And the filters that are being invoked are dynamic based upon the URL that is being requested. It's a little bit, it may be a little bit much to swallow, but we'll go over this in more detail and we'll see how it works with a few diagrams shortly. And by shortly, I mean now. So we're going to do a HTTP GET to messages, and our delegating filter proxy will delegate all the work to the FilterChain proxy. And remember, our FilterChain proxy is the Spring Security Filter Chain. It is what has multiple filters. And so multiple filters will see the request, and they aren't really that interesting right now, so we'll skim over them for right now. The exception translation filter will see the request, and it will try to invoke the rest of the application. Remember, that's how we want to word that. Try to invoke the filter chain or invoke the rest of our application, and it will catch any access denied exceptions. And then it will continue down to the security filter interceptor, and here it will look at our Spring Security configuration, and it'll ask, does slash match slash star star? And slash is essentially the URL that was passed in minus the context root. So that's where that's coming from. And earlier we said slash star star matches every URL, so the answer is yes. The current user must have role user because that is the access that is required for that intercept URL. And we're not logged in, so we'll throw an access denied exception. So it throws an access denied exception. The exception translation filter catches that exception. And what it does is at first it'll save the current request in an interface called request cache. And this is just a HTTP servlet request object that's saved in that request cache interface. And that'll come into play later. But just remember that we made a request for a particular URL. After you log in, you want to use the URL that you requested originally. This is how we replay that. So we'll get into more about that later, but just now know that we're saving a HTTP servlet request object. Then we're going to send the user to the login page, and we do that using Spring Security's authentication entry point. And you can customize that behavior if you want to write your own implementation of authentication entry point. So it sends us to the login page and using a redirect, and you might say, well, you said slash star star matches any URL. Well, why is that? We're using ANT patterns behind the scenes. And if you guys aren't familiar with ANT patterns, we're actually just going to go over the patterns real quick. But there's a couple other things to keep in mind. So when Spring Security matches on the URLs, query parameters are not included in the match. And you can do this, but it's not really encouraged and therefore not enabled by default. The reason for this is because oftentimes query parameters can be easy ways to bypass security constraints. So if you say, if the query parameter exists at the very beginning of the query string, it's difficult once you get 3 or 4 of them to say that they exist and it doesn't matter where they're at and it doesn't matter what the values are. It gets very complicated very quickly. Now there's an interface that you can implement that you could do whatever you want in order to determine if the request matches, but by default query parameters are not used in the match. And the context path is also not included in the match. And the reason for this is if you deploy your application again with a different context root, you don't want to have to reconfigure Spring Security. So the basic rules for ANT patterns are question mark matches 1 character, star matches 0 or more characters, but not a directory delimiter, so not a slash, and star star matches 0 or more directories in a path. So you might be thinking, huh? Or you might be thinking, I've used ANT, this is boring. So we'll go over a couple examples real quick for those that are still scratching their heads. So slash star star matches any URL. And that's pretty self-explanatory, so we won't have any examples for that one. Slash star matches anything in the root folder. So if your full path is slash messages slash 1, then the path that we're trying to match on is slash 1, because again, we aren't interested in the context root. We ignore that. And so that's in the root folder, so that will match. Slash messages slash 2 with the query parameter a equals b, that will be the path to match that we'll try to match on is slash 2, because again, context root we ignore, query parameters we ignore. So it's going to try to match on slash 2. And it does, because it's in the root folder. Slash 1 slash, it's not in the root folder, so it will not match. An example with the double star, so if we have slash 1 slash star star, it matches anything that starts with slash 1. Some of you might think, well, don't you mean slash 1 slash? No, it's a little bit confusing. It's actually anything that starts with slash. So our examples are, if it starts with slash 1, it'll match. If If it has some query parameters, again, it'll ignore them. If it's /1/, that matches also, and /1/view will match. Things that won't match are /other/ and /2/view. So one of the things that we mentioned earlier is URL-based security can be kind of fragile. And so it's very important to be careful and understand what patterns you're matching on and what patterns you have mapped your resources to. So let's take a look at this pattern, /*/star.css. This matches anything that ends with .css. So styles main.css, it matches. And this would be good because, we might want to allow access to all our CSS resources to anyone, grant access to anyone. Makes sense. /1, that doesn't match. So that means that our message, if we're viewing a detailed message, that's secure, so we don't have to worry about anyone seeing that. But if someone tried to invoke /1.css, it would be public. And you might say, well, why is that a problem? If you're viewing our message, well, if you're still logged in, it timed out. If you're viewing our application, you can see that Spring MVC ignores the .css extension by default because the best match is the /1, and it's trying to do content negotiation, and there's no additional information in our mappings. And so someone could actually request 1.css and bypass our constraints if we were doing that. So the moral here is the less restrictive our URL mappings are, the easier they are to bypass. So it's important to be careful how you're mapping your ANT patterns and to test them very thoroughly and to understand how your application maps to your URLs. And there's the other thing is that Spring MVC will treat the 1.css the same as 1 unless you otherwise configure it. So it's important to be aware of these things. And there's other ways to bypass URL-based security. For example, if you had a URL and you were trying to let anything that started with public be public, say public CSS or whatever, someone could request the URL /public /./admin. And it's a relative path, so it looks like it starts with public, but if it's supporting relative paths, all of a sudden they've got into the admin portion of your application. Now, Spring Security has a lot of things in place to protect you against these things. Relative paths will be denied by the HTTP firewall built into Spring Security. So there's a lot of things built into it, but the reality is that URL-based security can be rather fragile. And so it's best to combine URL-based security with method security. And this is what is known in the security industry as providing defense in depth. If one tier gets past, you get past one tier, you want to get secured in another tier. So now that we've gone over ANT patterns and some of the complications that come up with using them, let's see what happens when we request our login page. So now the URL is redirecting, our app is redirecting to the login page, and we're about to render it. So the DelegatingFilterProxy sees the URL again, and it delegates all the work to FilterChainProxy. And it skips over a number of filters that aren't very interesting for this request, and the default login page generating filter sees it. And it sees that the URL is Spring Security Login, and it's interested in that URL because it renders a login page for us for any URL that matches that. So it writes out the login page, and that's where you see that white login page coming from, is that default login page generating filter. And now the user fills out the username and password, and they submit it, and it'll typically be a post to JSpringSecurityCheck, and the usernames j_user and j_password for the HTTP parameters. And it comes in, and much of the same things happen, but this time the security context persistence filter sees it, and it sees that the HTTP session has no authentication in it, and so it's not really interested at this point in the request, but it will be shortly. Username password authentication filter, it sees the request, and it knows that it wants to process anything matching JSpringSecurityCheck. And so what it does is it validates the username password using the authentication manager that we have set up in our Spring configuration. And basically what it does is pass in the username and password. The authentication manager will then return a valid authentication object, and the username password authentication filter will place it in the security context holder. and the R is kind of hidden due to our screen resolution, but on the security context holder. But you'll see that the user is placed in the security context holder, and this is where Spring Security sees the currently logged in user at any point in time. So if there's a valid authentication on the security context holder, it doesn't care how it got there. It realizes that's the current user, and that's what it'll treat as the current user. So the most fundamental thing for authenticating a user is setting the security context holder. And that's why we can have different ways of authenticating a user and then use the same authorization logic or determining who has access rights to a particular resource without updating our code. So then the username password authentication filter is going to redirect to that saved request. Remember earlier we placed it in the request cache? It's going to redirect to that saved request. And it does that by redirecting to that URL that it was originally requested, but it can't encode all that information into the URL because there's headers that were in there, there might have been cookies, etc. There's all sorts of things that might have been in that request that can't be included in a redirect. So we'll get into how it deals with that in just a moment, but just now know that it redirects to the URL. And the security context persistence filter now notices that the security context was updated, and so it's going to save it in HTTP session. So anytime you save to update the security context holder, the security context persistence filter is in charge of updating HTTP session. And in fact, you don't have to store to HTTP session. That's implemented using an interface and an implementation, but that's the default mechanism. And so it updates it in HTTP session, and it clears out the security context holder. And this is because in web applications, threads are pooled. And so security context holder being a thread local, it needs to be cleared out, otherwise you'll have a memory leak. So now we have our HTTP session populated, and the user is authenticated, and we're requesting our originally requested URL. So the saved request comes in, and our delegating filter proxy sees it, delegates all the work to the FilterChain proxy. And the security context persistence filter sees the request, realizes that there is a user in session, and so what it does is it populates the security context holder. Now the rest of Spring Security can see that security context. And the request cache aware filter, this sees that there's a saved request in our request cache, and what it does is instead of invoking FilterChain.doFilter with the original request, which I would have notated as just request, it looks up the HTTP servlet request in the request cache and passes that to the FilterChain. And again, just as we said before, these are just interfaces, so we can implement it if we want, any way we want. And so basically we've stored that request, and now we're invoking the original request that was sent to the application through the FilterChain. And so now everything that was on the original request is in the request for this saved request. Now the security filter interceptor sees the request, and it sees that the current user has role user, and so it'll grant access and let the rest of the application process as normal. And it'll write out some sort of response. Security context persistence filter is returned to, and it sees that nothing has changed, so it doesn't have to update the session. But because we're using a thread local and threads are pooled, we do need to clear the security context holder out so that we don't have a memory leak. And so here we're just reiterating and demonstrating all of the discrete tasks that Spring Security has. Each filter has a discrete task and a specific function, and that allows you to reuse each of the filters as building blocks. And one of the things that you can think of is that a filter is actually acting as a controller. And so if you're having to customize some of these behaviors, some people are inclined to place it in a filter. This is fine if that's what you want, but some people get confused by this, or they lose functionality of their model view controller framework like Spring MVC. And so you can actually implement that logic in your controller if you want. Nothing's stopping you. So say you were doing your username password and you wanted to use JSON instead of a HTTP parameter. You could use your standard JSON library, convert the username password to strings, pass it into the authentication manager, and then you would be authenticated as soon as you set it on the security context holder. So just realize that because it's implemented in filters doesn't mean that you have to do it that way. Spring Security does this, A, because it's a way of doing it in an aspect-oriented way that's built into the container, and B, because well, I guess it kind of ties into the first one. It doesn't want you to require you to use any specific MVC framework. And so that's why it's using filters. It doesn't know what URLs you want it to process, so it needs to be able to arbitrarily determine at runtime which URLs to process. And it doesn't want you to require any particular MVC framework. So now that we've gotten through that, let's take a look and see what a custom login page would look like. So here you can see that we have our form login element, and we've added an additional attribute to it. The additional attribute is the login page attribute. And that login page attribute says that once you are accessing a URL and you're not authenticated, then and it requires authentication, then it should redirect to that URL. It also states that if you specify that attribute, that you are in charge of rendering that URL. So no longer will Spring Security create a login form for you, and you probably don't want that anyways because, let's face it, it's kind of ugly. But you are now in charge of rendering that URL. And you can also specify additional attributes. We only specified one other one here, but the authentication failure URL is where it'll go if you fail to authenticate, type in an invalid username or password. So there's additional attributes you can customize, the HTTP parameters that it looks for, etc. But you can refer to the documentation for that. So let's see what happens if that's the only update to our application that we make. If we make an HTTP GET to messages, it will eventually get to our exception translation filter. It'll do our try catch on the rest of our application. And then the security filter interceptor will determine if we have access. So does /match/**? Yes, so the current user must have role user. Not logged in, so we'll throw access denied exception. Catches the access denied exception. Now we're redirected to /login. So the URL has changed. The other thing is now we're requesting the login page and we're requesting the /login URL. And the exception translation filter sees it and it tries and catches it. Can anyone guess what's going to happen? Does anyone know what's going to happen? Yes, very good. It's going to do a loop. So security filter interceptor will say, does /login match /**? Yes, it does. So the user must have role user. And the user's not logged, no one's logged in, so we're throwing an access denied exception. And we repeat. So you'll say, well, that kind of sucks. Spring Security actually gives you a warning stating that this is the case, but that you basically probably have a bad configuration. But the way that you fix this, actually I think I have it in the slides, the way that you fix this is by adding another intercept URL pattern. And it's important to realize that these intercept patterns are considered in order. So if we had the /** first, it would match every URL. It would never get to the /login. So you want to place that first. And so we say that if it matches /login, then we will grant access to that URL. So now, how do we create our login JSP? And the login JSP only has a few rules. And in fact, it doesn't have to be a JSP. We just chose to use JSPs. If you're wanting to learn other templating technologies, a little plug for my next presentation in the next session is templating with modern templating languages with Spring MVC. So if you don't want to use JSPs, you could use whatever you wanted. But there are some rules to how this request must be formulated. First of all, you'll want to submit to the URL JSpringSecurityCheck. This can be customized, but by default, that's the URL you need to post to because that's what our username password authentication filter is listening to. You also must do a post. This can be customized as well, but it's not a good idea because you always want to send sensitive data over HTTP post. So once you've done that, then you need to ensure that you have the username and password, and the username password should be j_username and j_password parameters. Again, these can be customized, but by default, those are the HTTP parameters that the filter is looking for. And you'll also notice in here that I have param.error not equal null, and if so, display failed to log in. This is how I'm displaying the error for logging in to our users. And I can get the details of how they failed to log in using the Spring Security last exception. And so we've done all these, so let's take a look and see what will happen in our application if we update it. And I tried to get most of this typed out so we could move along and not see me type too long. So now we can access our URL, and you see that I get a much nicer, well, maybe some would argue it's not much nicer, but it's relatively nicer login screen. And I'm able to log in with it just as I was before. But one of the things that you'll still notice is that when I try to log in and I have an invalid username password, I do get this failed to log in, but it's not actually repopulating my username. In fact, Chrome is what's populating the admin again as opposed to the other one because it was blank. So basically, in summary, if Chrome was not autofilling in admin for me, it would be blank. So you might wonder, well, I want to integrate with the MVC framework of my choice. And of course, you guys are at SpringOne, so we all know your MVC framework of choice is Spring MVC. So we'll see how we can do that real quickly. Just going to update our mapping real quick before I forget. And so all this is doing is it's mapping our /login URL to a different view that we have. And here, what we're doing is we have our login.jsp, and there's nothing fancy about it. Again, you don't have to use JSPs if you don't want to, but now we're submitting to /login, and we're submitting to /login because we are going to process that URL in Spring MVC. And I'll show you how to do that in just a moment. So we're submitting a post to /login, and we're going to be in charge of rendering it. Everything else should look very familiar. We're able to reuse the JSP form errors tag, so we can display our errors without using Spring Security's last exception as we did before. And our username and password are using the form JSP tags as well, so they'll be automatically repopulated. So let's see this in action real quick. You won't see much of a difference in terms of UI other than the fact that now when I type in user and so now you'll see that the password is required. So we're also getting form validation on here as well. And it also gives the bad username password. So these are all populated using Spring MVC's standard support. And this goes back to what I was saying earlier. We can do this logic with Spring MVC or whatever you want. You don't have to use filters. So let's see how we're doing this in our controller. I think I went to the wrong method. So this is the method that we're actually using right now. And you can see that we've mapped it to /login in a post. And it's probably a little difficult to see. We'll try to add a new line, a couple new lines for you. And so it should look pretty much like what you would expect a Spring MVC application to look like. There's a little bit of stuff in there that we probably don't really like we have the HTTP servlet request being passed in. Normally you want to abstract that out, but you'll see why we're doing that in just a moment. So we have a form login, and our login form, and the login form is pretty much just a standard form with Spring MVC. We added not empty to the username and password, and again we're using j_username, j_password. That's just to make things easy. You could use whatever parameters you want. it's functioning just as Spring MVC would. You don't have to update any Spring Security configuration to change those. And so what you do is you get those username and password, and then you can validate it any way you want. Right now, we're validating it using does the username equal the password? And we're also validating it because earlier we said that we also wanted to check to see if they were non-empty. So that was that's because of our @valid annotation and the not empty annotations on the form. So you could very easily authenticate in any way you want. And so how that's happening is once you validate it in any way that you want, you could just do nothing if you wanted. You can then authenticate the user. And it's a little difficult to see. Probably make some new lines here for us. So what you can do is you can create a new authentication, and that authentication might be a username password authentication token, and you can specify the roles that you want for that user. Right now we aren't using the authentication manager, so we're just going to hard code role user for right now. And then you set the authentication on the security context holder. And this goes back to what I said earlier. It doesn't matter how this security context gets populated. As long as it's populated, the rest of Spring Security will behave just as it normally does. So for example, say you have a user trying to sign up for your application, and you want them to log in immediately after they have signed up. You don't want them to have to log in again manually. So you could create the user just as you would normally in your domain, and then you can create a new authentication and set it on the security context, and they'll be authenticated. And again, the reason why this gets added to Spring Security long-term is because our security context persistence filter that we discussed earlier. So once you've done that, one of the things that people ask is, well, then how do I replay the original request? Remember earlier we talked about the request cache, and we thought, well, we want to replay the original request before they logged in, so how do we do that? Well, you can auto-wire an authentication success handler to your controller, and this is what Spring Security is using behind the scenes in order to redirect the user in the username password authentication filter. So you can just use the same interface, which accepts a HTTP servlet request and response, and that's why you see that. And so you can do this. You can do this as well. So you might ask, well, I don't want to validate the user myself. I want to use the authentication manager. Well, that's also an option. I was just showing you if you wanted, you don't have to use the authentication manager. It's just there to help you if you view it as a way to help. So another way you could do it is you could do the exact same thing we saw earlier, and instead you could create an authentication token using the authentication manager. So what we do is we pass in a token that's not authenticated, so there's just a username password passed into it, and then we pass that into the authentication manager. And remember earlier in our diagram we said the authentication manager will then return a validated authentication object. So it returns that object, and then we set it on our security context holder. Again, nothing magical about it, just set it. And then we can use our success handler to send us to the success page. Now if there's an error logging in with the authentication manager, the contract is it'll throw an authentication exception. So what we can do is we can, in Spring MVC, we can just reject that error with an error and specify the message on that exception, because Spring Security's exceptions are already internationalized. And then it sends us back to the login view. So again, you could do all the logic in the filters in your Spring MVC controllers or whatever framework you want. But it's important to be aware of how it's working and how things are put together so that you can make these things as easy on yourself as possible. So we've talked about a single HTTP element, but Spring Security introduced multiple HTTP element support in Spring Security 3.1. And so you don't need a single HTTP element. This could be useful if you're using REST services and a HTML-based web application in the same application and you want to secure them differently. And we're only going to give a very basic demonstration of how it works, but we want to demonstrate how the flow is traced in our application. So here you can see that we're requesting main.css. And again, DelegatingFilterProxy sees it, delegates all the work to FilterChainProxy. So now we've updated our security.xml file, and what it's really doing behind the scenes is that the DelegatingFilterProxy is delegating to the FilterChainProxy, but earlier we alluded to the fact that the number of filters in the FilterChainProxy that it delegates to changes based upon the request URL. So here you can see that I've added another HTTP element. So the filters for the first HTTP element will be different than the filters for the second HTTP element. Go over that in a little bit more detail. So what happens is that if you look at this HTTP element, it also has a pattern element on it, similar to the intercept URL. But this pattern is determining which HTTP element we select. So right now the yellow arrow indicates we're seeing if it matches that. So does main CSS match the resources ***? Yes, it does. So we select that HTTP element, and security is disabled because if you look at it, we specified security equals none. So what that is doing is rather than saying we're granting access to everything, it's actually saying that the filter chain isn't going through any of the security filters. So remember earlier we notated it with lots of small little boxes and saying we weren't interested in it? Well, it actually skips over all those boxes because they aren't even added. And we write out the response. Our application writes out the response as it normally would. Let's see what happens when we request a URL other than resources. So here we're requesting /messages/. So does / match /resources ***? No, it doesn't. So now we're going to go to the next HTTP element. Does / match /**? And this /** is on the HTTP element itself. It's not the intercept URL. It's the HTTP element itself. And the reason why it's /** is the default pattern for HTTP element is /**. So again, just like the intercept URLs are considered in order, so are the HTTP elements. So you don't want to place the /** one first, because otherwise you'll never get to the second one. And Spring Security will actually give you an error if you do this incorrectly. So it does match /**, so we're selecting this HTTP element. Now we're going inside the HTTP element, and we'll determine if the pattern matches the current URL. And / does match /**, and so we require the role user. Let's see what happens when we do a slightly different CSS request with a little different configuration than we saw earlier. So now we have two HTTP elements, and we introduced another intercept URL. So we aren't saying, actually that's incorrect. The security equals none should not be on there. I apologize for that, but the HTTP element basically gets the intercept URL and the pattern on the HTTP element and says, does main CSS match resources /**? And yes, it does. So it's selecting this HTTP element. Now, our pattern is resources admin.css. So does main CSS match admin CSS? No, it does not. It does not match it. And there's no more patterns for this HTTP element, so we're going to grant access. And that might be a little bit confusing because you see another HTTP element right below that and another intercept URL pattern that says match everything. But the key is once it matches on an HTTP element, it's already decided all the filters that are being used for it and all the security patterns and everything. So once it gets into that HTTP element, it's isolated to that HTTP element. It will not go to another one. So that's why we're granting access. Let's see how we can add logout to our application now. Logout is pretty easy. All you need to do is add the security logout element. And I'll try to get that a little bit higher so you can see it, hopefully. The logout element, which is right here, the logout element basically has a logout success URL, similar to how the authentication failure URL exists. And all we need to do in order to leverage that is update our application to point to the URL it's listening to. So very similarly to the URL that we send the username password to, there's a default URL for a logout. And that default URL is JSpringSecurityCheck. And I'm going to just pull this out because we're going to do another thing in just a moment, but we want to illustrate a point first. And I want you to be able to see that. So all we need to do is create a link with JSpringSecurity logout, and you can customize that URL as we mentioned earlier. So now that we've created that, we'll go into our application, and we'll see that we have a logout link. And we aren't logged in, so that's kind of weird, but we'll get to that in a moment. So now I'm logged in, and I have a logout link, and I can log out. Nothing spectacular. You'll notice the URL, after we're done being logged out, has the query parameter logout on it, and that's why we're able to see this logout success message. Now, in our JSP, we're checking for that query parameter and always displaying it, but if you wanted, you could also use Spring MVC to intercept that URL and add a flash attribute and display things as you would normally in Spring MVC. So we didn't do that, but it should be pretty self-explanatory on how to do that at this point. But one thing you'll notice is that we pointed out earlier is the logout link is still displayed and we're logged out. Spring Security provides a JSP library that allows us to hide things in our JSPs based upon the current user. So here you'll see that I have the security tag, and the security tag we should probably... The security tag has a namespace just as any other tag does. And then we declare the authorized tag, and we say access equals authenticated. And this access attribute is very similar to the one we saw in our Spring Security configuration earlier. This is just a keyword that says, if the user is authenticated, I will grant access. So we get into this authorized statement, and then we're able to say, welcome to the current user. How does this work behind the scenes? Well, there's an authentication tag, and it does all the work. Enough said. Not quite. So the authentication tag is using our security context holder, just like the rest of Spring Security. So let's look at our security context holder. Of course, the source is not attached. See if another one. There we go. So we have a get context on there, and this is where the context comes from. And then when we get that, the tag is getting this authentication object off of there. So it calls get authentication. And then authentication extends principal, which has a name property. You might not be able to see, but at the very bottom it says get name. And so the way this is working is authentication in our JSP, it's getting the authentication, and then it gets the name property off of that. And that's how it's working. If you had your own custom authentication object, you could add like a first and last name to it if you wanted. You could add, an organization, whatever you wanted. So this tag can access any property on the authentication object. And then we have our logout link also, and that's between the authorized tags. So you shouldn't see it anymore unless you're logged in, or unless I have an error. What's funny is I've practiced this a number of times, and that always happens. All right, so now we're logged out, and we don't have the logout link displayed up there, but we can log in with our, if I type in the right password. If I log in with admin, I see welcome admin in the upper right. If I log out, I can log in with user. And I typed the wrong password. Sorry about that. And I'm now logged in as user. So you can see that it's relatively easy to add this sort of customization to your web application. And this is some of the stuff that we've already covered. We won't go over it again. So now we talked about method level security, and you must do it. So if you must do it, then we must cover it as well. So let's take a look and revisit that issue that we saw earlier. So if we create a message, actually I need to update our configuration, I apologize. So we need to simulate the situation that we saw earlier. So in order to do that, let's grant access to any URL that ends in CSS. And we realize this is a vulnerability already, but we want to demonstrate how we can catch these errors. You know, if we miss something like this, how Spring Security method level security can help us. So now we've granted access to any URL that ends in .css. So as we discussed earlier, that means that if we access one of our messages with the .css suffix, we'll have access to it. So let's create a new message, and we'll create the new message, hello world. And now we have that message, and I'm going to copy that URL and I'll log out. So if I paste the message, I get a login screen. This is exactly what we were hoping for. But if we know what we're doing, we can type in one.css and we see that Spring MVC is mapping that to our message resource. And this is not what we want at all. So how are we going to get around that? Or how are we going to prevent malicious users from getting around that? Might be a better way of phrasing it. So the easiest way is to add method level security. And I'll go over how this works in the slides because it'll be a little easier to see than the IDE, but I'm just updating the code here real quick. So the first thing you do is you update your security.xml to have global method security in it. And then depending on the annotations that you want to process, you enable those as well. Here we're going to use pre and post annotations. Then you need to add some sort of annotation to your message repository. And we didn't really go over this, but the message repository is basically our data access tier, our service tier, and this is where we can add these sort of security constraints. And we'll go over that in more detail when we update our app, because I still need to update that. And what's happening here is we have an application context that's represented by the green, or depending on how good the quality of the monitor is, maybe that's yellow. I'm not really sure what it looks like to you guys. But the application context is that big box, and it has a number of objects inside of it. And one of them is the message repository. And what happens is Spring Security will register a bean post processor inside that application context. And what it does is it looks over all your beans in your Spring configuration. And this is nice because it can actually modify them before it injects them into your objects. So it iterates over each of them, and it says, should I secure this object? And in fact, message repository, it should secure it because it sees one of the security annotations on it. So it turns it into a new object, secure message repository. And this is just a name I gave it. It's actually auto-generated proxy object using Spring's AOP support. But fundamentally, this is what it's doing behind the scenes. It creates this new implementation, and what it does is it replaces the methods with those annotations with checks. So earlier we said in a filter we can do something before and something after. We can do the same thing with method level security. So we could say before we invoke the delegate, which is the original message repository that we had, before we invoke it, do some sort of check. And if that passes, then we'll go ahead and invoke the original method, and then afterwards we could do some other sort of check. And so let's see how we can do that in our application. So we've already enabled this in our Spring Security configuration. And I'm not going to use this annotation just yet. We're going to require the role user for this method to be invoked. And hopefully I type everything correctly. So in order to invoke this method, now the user must be logged in and they must have the role user. So let's see what happens when we try to bypass security now. First, we'll go ahead and create our message just so we demonstrate that we're not cheating somehow. We'll create our message. And we'll copy the URL. And so we'll log out. Now, if we type in the original URL without the .css, we get the login page just as we did before. But now if we type in with .css, we get the login page again. And what's happening is, as we mentioned before, it's creating a proxy object and it's doing the access control check just as our filters were earlier. So now we have 2 layers of security. So if we get past one, we have another layer of defense. And this is what we want. So you might say, okay, well, role user is kind of cool, but what else can I do with Spring Security's annotation-based security? Spring Security's annotation-based security also supports Spring expression language. And if you guys aren't familiar with Spring expression language, it's very similar to something like JSTL. There's a number of other similar things, but here you'll see that we have a post-authorize, and the pre-authorize is before the method is invoked. So the post-authorize is after it's invoked. So remember our original object, we said that we could do something before and after. Pre maps to before, post maps to after. Self-explanatory, but why would I want to do something after? Well, what if something on the object could be used to determine if the user has access? So if you remember, our message object has a summary property. So the return object specifies what we're returning. It's just a keyword within Spring's expression language support. So the return object, if that summary equals the current user's name, then I'll grant access. And like I said, if there's a property on that object that you have to look up anyways, you might as well just look it up and just not let the user see it if they aren't allowed to access it. So let's see how this works. So now I'm logged in as the admin, and I'm going to create a new message. And I'll create one with the summary of admin. So I'm able to see this just fine. If I create another message with the summary of user, I get an access denied exception. And this shows that if you try to bypass it, it's going to give you an error. And we can also log out and log in as our user. Now if I view the admin one, I get access denied. And if I view the user one, I'm able to view it. So it's something that you can use to relate the properties on your returned objects to your user. And there's actually other abstractions that you can use in order to make this even better. So Spring Security has ACL support. So you can map a particular domain object to a set of roles or users and grant access that way. And we won't have time to get into all that stuff today, but you can read about it more in the documentation. And I think that was actually all that's in the slides, but we are going to have time for our bonus. So give me 1 second to set that up. So what I'm doing now is I have another branch of my project. And this other branch is set up to use what I have started as Spring Security Java config. So one of the things that people have been asking for a while now is, how can I configure Spring Security with Java configuration? And this has been something that's been fairly challenging. If you've paid attention to the Spring Source blog, Luke Taylor, the previous Spring Security lead, had worked on something with Scala support. And that worked very well because Scala allows us to have multiple different, essentially it allows you to inherit multiple times. We won't get into the details of exactly what I mean by that, but you can have multiple inheritance. And this makes sense because if you look at it, the configuration has something you might want to say with login form, or you might want to say with OpenID or with logout, and you can't have multiple types of inheritance, and the configurations get very complicated, basically. So Scala allowed us to do this. Aspects would also allow us to, but it's been something that's been challenging for some of the more complicated projects. So first we'll demonstrate that things are not working. That really wasn't my intent. Things are just not working. Oh, my class, I don't think I'm going to be able to get that too. I'm betting this is not going to work because I don't have any Wi-Fi and I had to clear out all the dependencies, but we'll give it a shot. Basically, I need cglib on my class path. And when I cleared them out, I was on the other branch that didn't have cglib on the class path. So I have it here. We'll see if it finds it. Otherwise, we'll just go over the code and you can try it on your own when there's an internet connection. I think it's trying to download it, which, well, maybe. Nope, build successful, it claims. No, it's getting an error. Yeah, it can't find that dependency. So I apologize, I kind of botched that, but we can show you what it looks like, and we can see how that works here. We might be able to, after we go over the configuration, try to get the wireless set up. I can't remember what the username and password is, but maybe someone can remind me. But we'll go over this first because I think this is probably more pertinent to than seeing the demonstration, because you won't really see anything different in the application's behavior. So the Java configuration support is more than super beta. This is actually something I put together in probably a couple days' time. It's not actually as a separate module, it's just built into this application. But this is probably where the Java configuration is going to be going for Spring Security. And the way that it's going to work, at least tentatively, is using builders. So instead of XML, we'll be able to specify something like this. So here's our Authentication Manager builder. And you can see that we can add users to our in-memory user details service, just as we saw in our XML configuration. And so it shouldn't look all that surprising. But one of the things that you'll notice is one thing I'm going to try to make sure is that things are as concise as possible. So if you use the roles method to add the granted authorities, you don't have to say role user, role admin. You're just going to say .roles. And it'll automatically add those prefixes for you. And another example might be the intercept URLs. Earlier you had to have multiple intercept URL definitions if you had multiple URLs that map to the same pattern. So here, this is kind of hard to see, so let me excuse the indentation, but otherwise you won't see this. So here we add an intercept URL with the ANT matchers of resources, sign up, login, logout, and we're granting access to all of those. Previously we had to say permit all, permit all, permit all, permit all. So now we're able to do this much more flexibly. In addition, you'll have all the objects available to you just as you would with the standard Spring configuration with Java config. Another thing that we'll try to do is that we'll try to provide some more reasonable defaults for you. So for example, if you're adding a login form and you specify the URL as /login, you won't get the infinite redirect loop. You won't have to reconfigure that URL as a URL that is public. It will automatically realize that because you are configuring a form login. Now you'll have to invoke a method because URLs aren't the only thing that are used to determine a request. So in security you want to be safe than sorry, rather be safe than sorry. But you'll just invoke a method and any objects, any URLs that's configuring, it will automatically make public. So this is the basic configuration of how things would be laid out, and this will be available on the web. But one of the things that's interesting about this is we're using this builder object, and the builder object's creating multiple multiple things that we need to expose to our Spring MVC or our Spring configuration. So we, just as the other objects have an enable annotation, so does Spring Security. So these are some of the things that Jürgen was talking about in our in the speech last night. And what we've done is we're importing the web security configuration. And what this does is it's auto-wiring our FilterChainProxy builder, which is the builder object that we were talking about earlier. And then it exposes multiple objects on that builder to as beans in our Spring configuration. And so that's how we're getting around some of the limitations that we've had trouble with in the past. And again, this is super beta, but I wanted to show it to you guys in case anyone in here already was familiar with Spring Security and sat through the whole introduction. They had something to go home with that might be a little bit exciting. So anyways, that concludes my presentation. I apologize for not getting the demo working here, but I assure you it'll run just pretty much the exact same as the app that we saw with the XML configuration. And if you have an internet connection, it should work just fine. So with that said, I believe we have a little bit of time for questions. Do we have any?
A little bit more advanced question.
Sure.
If you had two users on the same system, web app, you have an admin and a user. The admin, they're both logged in, they're both actively using the system. The admin changes the authorities for the user.
Mm-hmm.
How would you go about doing that in real time so it took immediate effect? You didn't wait for the user to log out and then log back.
So the question is, let's say you have two users, one's an admin and you have another one that's a user, and you want the user's roles to be impacted immediately. So earlier we mentioned that the security context persistence filter uses an interface in order to discover and map the current user. So one option you could have is you could actually put that in something that's distributed. So for example, you might put it in a distributed cache. And in that event, when the administrator looks up that user, you'd have an API that could look up the user in the distributed cache, update the roles, and then the next time the user invoked the request, they would retrieve it from the distributed cache. So that's one option for doing that. There are other options. You could use mbeans, but then the mbeans are then being exposed to. You're basically adding a lot of things to memory because essentially that's what mbeans are. So I mean, it kind of depends on the scale of your application, but probably the best approach would be updating the security context repository interface to point something to something that could load that's shared across all your cluster. I assume you're in a clustered environment. So, good question. Yes?
For method level security, if we wanted to address those methods, would we be able to bypass that, or would we need to create a test user and test database?
So if you, the question is, if you want to unit test methods that are using the method level security, could you unit test it without setting up the users? And the answer is yes. The only reason those annotations are processed is the XML that we saw, the global security, global method security element. So remember when we added that to our security XML file? If you don't have that anywhere in your Spring configuration for your tests, then the annotations aren't processed, so it'll just be a regular object. Does that make sense? Right over here.
Can we use Spring Security for RESTful services? And can we specify the request type in addition to the URL?
So request type being the content type or the method? Method? Yeah, in the intercept URLs you can specify the method. And so another thing that's important to realize too is the intercept URLs using these ANT patterns is the default mechanism for Spring Security. It's actually backed by an interface called Request Matcher that will allow you to pass in an HTTP Servlet request object and it'll return true or false. So you can implement that interface any way you see fit if it's not meeting your needs. Now hopefully we'll be getting some better support for that now that if we have the Java configuration, we'll probably be able to customize that a little easier. So we might have, you might see some better support for other types of request matchers creep into Spring Security when that comes up. But again, this is super beta. I've only been on officially for about 4 months, and my first task was to get our bugs down to a minimum, and we've done that now. So now we're starting to add new features. So good question, though. I think she's been raising her hand for a while. Yeah. I'm sorry, can you speak up? It's hard to hear. NTLM? Uh-huh. NTLM support is kind of deprecated in favor of the Kerberos support. Yep. Yeah, it actually, you're correct. Kerberos support has not been actively maintained for a while, and hopefully some of these extension projects will, basically, if you're not familiar with the extension projects are kind of maintained and contributed by outside contributors. But hopefully I will be able to have some time to start helping contribute to those. But it'll be a matter of working with those leads, because it's not very community friendly if I go behind their back, so to speak. So I'm sure that they'll be welcome to it, but it'll involve a little bit of politics as well. But that is the plan, is to start picking up some of the support for some of the extensions, and I'm going to try to add that to some of the things that I help actively maintain. So I don't know if that answers your question, but that's about the best I have for you. Anyone else? Yes, sir?
Say we use Spring Security to secure some RESTful web service.
Uh-huh.
Client side, we use jQuery Ajax, Column,
Yep.
RESTful web service. How security is going to be, how the credential is going to be passed to them.
And that actually will vary depending on your solution. So actually, let me repeat the question real quick. The question was, if I have a client that's written in JavaScript and I'm calling RESTful services, how do I store the credentials for the client? And so the answer is that'll depend based upon your application. So for example, if you're using a web-based application, you can just use the HTTP session. And I know a lot of you may say, well, HTTP session, that's state. I hate state because I'm RESTful. And to an extent, that's true, but you must realize that the important thing to realize is that HTTP session is just another way of caching something. So if the user's not logged in anymore, it fails over. You can either set up a distributed HTTP session failover, stuff like that. But if all that fails, then essentially all that happens is the user is requested to log in. And so you can think of the session ID as no different than a person identifier or a user identifier, or if you're storing medicine identifier, and it's looking that up. And it might be looking it up in a distributed cache, or it might be session. Session is technically, if it's a distributed session, technically a distributed cache. Now with all that said, if you don't like that answer, which some of you are probably not liking that answer, you have other options. I mean, you can use something like OAuth. You could use like the OAuth extension. You could store that. But I mean, the reality is you're going to have to store it somewhere, and whenever you're leaving state for the server, you're pushing it to the client. And if you push it to a client that anyone can see, you want it to be very, very short-lived, because otherwise you're having a security vulnerability. So that's the good thing about state, is if it gets compromised, you can destroy it. If there's no state, there's nothing to destroy, and you've been compromised. So that's something to keep in mind. Does that help at all? I don't know if you still had a question. I saw you had your... Oh, okay. Okay. In the back? Oh, so you're asking if you only want to encrypt part of your application? Okay, so I'm going to answer this, and this is probably not going to be the answer you're looking for, but I'm going to stick with it. So basically, it's not good practice to do that, and I'll tell you why. Because anyone here heard of Firesheep? Raise your hand. Firesheep? So basically what happens is, as soon as you enter that username password, what is protecting your users? It's the HTTP session. The HTTP session is going across the wire in plain text now, and anyone can intercept it. So if you are not familiar with what I'm talking about, Google Firesheep. But basically what it amounts to is only protecting the username password will only get you so far, and it's really not the right approach. And a lot of people say, well, SSL, that's expensive. We can't afford SSL for the load that we have. Try it before you actually say that. There's a lot of people that have said that, and they've actually tried it, and they were surprised. I mean, I know I'll use this example, and you're like, well, we're not that company, but Google uses SSL for everything as well. And now, yeah, you're not Google. You probably don't have the resources. Maybe you are Google. I don't know. But you don't have the resources that they have, but you probably don't have the load that they have. You probably have resources relative to the load that you have. And in all honesty, the other thing is, all the data that you're transferring over the wire, that's not encrypted either. So even if you protected the session ID, say I'm in a medical application, and I'm searching for medications, and the medication implied that I had AIDS. All of a sudden, they know that I have AIDS. And so or my bank information. My bank account is being transferred across the wire. So most likely, if you're authenticating to the application, you're wanting to secure the data anyways. So in summary, use SSL. I think that's about all the time we have for questions today. If you have any others, feel free to get me later. Thank you.